So in this video, we're going to go over the problems that are in the Unit 4 test review. So in this first one, we want to add these polynomials together. Okay, so if we want to add polynomials, remember you always want to check that the polynomial is in standard form. And you also want to check for any skipped terms, right? So we want to make sure that it's going in order, like highest degree to lowest degree. And we want to make sure that, like, for example, here we're doing x cubed, x squared, x, and then the constant term, right? Since this is quadratic, we want it to be x squared, x, and then the constant term. So in this first polynomial, notice that there's no x term. So I'm going to go ahead and add that in. So 0x and then plus 7. And then I'm going to combine the like terms, right? So like terms combining is very, very important when you're adding polynomials. So I'm going to go ahead and write 3x squared plus 4x plus 3. And then I'm going to combine the like terms. And then so I'm just going to, 5x cubed has nothing to combine with. So I'm just going to put 5x cubed minus 2x squared and plus 3x squared. That's going to be plus x squared. 0x plus 4x is plus 4x. And then 7 plus 3 is 10. So this is now the answer. It can't be simplified any further, and so you just leave it like that. Okay, so now let's try number 2. So number 2 says to factor completely, and we have a trinomial, which is a quadratic, right? So remember, whenever we have quadratic trinomials, they're ax squared plus bx plus c, right? So what we need to do is we need to first look at a times c. So a times c is 3 times negative 35, and 3 times negative 35 is negative 105. So now what we need to do is list out the factors of 105. So like 1 and 105. And then 105 divided by 3 gives us 3 and 35. And then 105 divided by 5 gives us 5 and 21. And then 105 divided by 7 gives us 7 and 15. So now if we look at this, okay, 105 is negative, so we need a positive factor and a negative factor, right? And then if we look at B is positive, right? So that means that we're going to make all of these bigger factors positive and the smaller factors all negative. So the correct combination that's going to give us a total of 8, right? Because this needs to be our sum. So the total of 8 is going to be negative 7 and 15. So remember, we cannot just write x minus 7, x plus 15, right? Because that doesn't work because this is a situation where a is not equal to 1. When a is not equal to 1, we actually need to expand out that middle term. So we're going to write it as 3x squared minus 7x plus 15x minus 35. So let's put these factors now into two groups. So we have 3x squared minus 7x and then plus, and then we have 15x minus 35. And now we're going to look at the GCF of each group. So if we look at this first group, the GCF we can factor out as x. You can call it 1x if you want to, but I'm just going to write it as x, and then we're going to divide it out of both terms. So we divide it out of both terms, and that's going to leave us with x times 3x minus 7, and then plus, and then from the second group, we're going to factor out 5, and then we do 15x divided by 5 minus 35 divided by 5. So that's going to be plus 5. And then so 15 over 5 gives us 3. And then we have 3x and then minus 35 divided by 5, which is 7. So this common binomial we're going to factor out. So we do 3x minus 7. And then whatever's left, the x plus 5, just becomes the second binomial factor. So this is the factored form of this expression. So now let's go ahead and try number 3. So number 3 is subtraction. So remember, subtraction, what we do is we rewrite it as an addition problem, right? Except this case, we're going to be adding the opposite. So instead of this minus, we're going to turn this into a plus negative. So now this negative is going to distribute to all of these terms. So we have plus, and then so instead of 3x squared, that'll become negative 3x squared. Instead of minus 2x, that becomes plus 2x. And instead of plus 4, that becomes minus 4. So we have 5x squared plus 4x minus 6, and then we have minus 3x squared plus 2x, and then minus 4. Okay, so let's add these now together. 5x squared minus 3x squared is 2x squared. 4x plus 2x is plus 6x. Minus 6 minus 4 gives me minus 10, so that is now the fully simplified form of the answer. Okay, so here it wants us to divide, right? So since this is an x minus r polynomial, right? It's just a linear binomial. I would actually recommend using synthetic division because I think it's the quickest. If you really want to use long division, you can. But remember, when we talk about r, we're going to switch the sign that's there. So this is going to be r equals negative 2. So we put negative 2 in the box, and now we're going to expand out this polynomial, right? So we have x cubed, and then we go minus 2x squared. The next one should be a 0x term because we don't have an x term here, and then we have 3. So I'm going to use these coefficients to go here. So we have 1, negative 2, 0, and 3. Okay, so first we're going to bring down 1. Okay, then we have 1. Remember, you bring down 1 and then you multiply by negative 2. So 1 times negative 2 gives me negative 2, and then we add these two numbers together. So negative 2 plus negative 2 gives me negative 4. Once again, we multiply by negative 2, so negative 4 times negative 2 is 8. 0 plus 8 is 8. 8 times negative 2 is negative 16. And then 3 plus negative 16 is negative 13. Okay? So this was a cubic to begin with, right? Third degree. So it's going to go down 1 degree. So we have x squared, this is x, and then this is the constant. And then this is now going to be my remainder. So what I'm going to do is I'm going to write this as like x squared. You can write 1x squared, but we usually don't write coefficients of 1. So x squared minus 4x plus 8, and then minus 13. And then remember, we write the remainder as a fraction. So minus 13 over x plus 2. Okay, so that is now the quotient that we find when we divide. Okay, so now here it wants us to factor this. So this is a cubic polynomial, right? So I will show you the quickest way to factor. The quickest way to factor is actually to use Desmos, okay? Because what will happen is Desmos will tell us the x-intercepts, okay? So the x-intercepts are going to tell us the roots, which are written as r, right? So the roots are the place where the function is equal to 0. So that's why we find them at the x-intercepts. So that means that the factors are going to be all in the form x minus r. And really, this is like the quick 5-minute way of doing it. If you want to see the longer way of doing it, make sure that you check the 4.09 and 4.10 videos that are in the course, and it'll show you how you do this with synthetic division. But like for this test, all you really need to do is go to Desmos, and you can see there are 3 roots, right? Which makes sense because the fundamental theory of algebra tells us that if we have degree 3, we have 3 roots. So the roots that I have are negative 4, right? I'm just going to write down the x coordinates, and then I have 3, and I have 5. So if I have negative 4, okay, so I'm going to write the factor as x minus negative 4. Well, minus negative becomes plus, so that's going to be x plus 4. Then when I have 3, we have x minus 3, right? And so that I don't need to change. And then I finally have that x minus 5. Okay, so this is now the fully factored form of this polynomial. And you can do this all just by going to Desmos. Okay, here it says which statement is true about f of x equals x to the fourth plus 4x cubed minus 11x squared minus 30x. So you notice here it wants us to check factors and what the value is, okay? So if something is a factor, the remainder is going to be 0 when I do synthetic division. And so that's how I'm going to check answer choice A. So basically the strategy on this problem is to check answer choices and then just eliminate. So remember the coefficient of this is going to be 1. Also notice I don't have a constant term, so I'm going to add in a 0 to the end. So let's first check if x plus 3 is a factor. So we're going to put the minus 3 here, and we have 1, 4, negative 11, negative 30, and 0. And then so first we bring down 1. Okay, we do negative 3 times 1, which is negative 3. And then 4 plus negative 3 is 1. Negative 3 times 1 is negative 3. And then negative 11 plus negative 3 is negative 14. Negative 14 times negative 3, that's going to give me 42. Negative 30 plus 42 is 12. Negative 3 times 12 is negative 36, and then 0 plus negative 36 is negative 36. Okay, so that is not equal to 0. Doesn't matter what kind of number it is. It can be positive, negative, fraction, decimal. As long as it's not 0, then it's not a factor. How do you check if f of negative 3 equals 0? Remember, you can do synthetic substitution, which is the exact same thing as synthetic division, right? When we plug in that negative 3. So since that is not equal to 0, we also know that b is not true, okay? Because this answer right here is actually telling us the value of f of negative 3, right? That's the remainder theorem. Now it says f of x when divided by x minus 3 has a remainder of 0. Okay, so if we have x minus 3, remember x minus r tells us r equals 3. So we put the 3 in the corner, right? And then let's do synthetic division here and see if we have a remainder of 0. Okay, so I'm going to bring 1, and then we do 1 times 3, which is 3, right? And then 4 plus 3 is 7. 3 times 7 is 21, and so negative 11 plus 21 gives me 10. 10 times 3 is 30, and then negative 30 plus 30 is 0. Okay, and then we have 0 times 3, which is 0, so 0 plus 0 is 0. So answer choice D does look like it's correct because when we divide by x minus 3, notice that we get a remainder of 0. It says f of x equals 0 when x equals negative 3. Once again, we can use our synthetic substitution that we did here to figure this out. Notice that it does not equal 0 because, right, we got negative 36. So that means that D is also incorrect. So that means that C is the correct answer choice. Okay, so here it says one of the zeros of the following polynomial function is 2. What is the fully factored form of the function? If we know that one of the zeros, okay, that also tells us the value of one of the roots. So this is like saying r equals 2. So we know that x minus 2 is one of the factors of this function. So anytime you're trying to factor a polynomial, the absolute quickest way to do it is actually to go to Desmos and type in your polynomial. So x to the fourth minus x cubed minus 32x squared minus 12x plus 144. Okay. And you'll see the roots here in Desmos. So we have, let's see, roots of -4, -3. We also have this root here at 2 and this root at 6. So 2 and 6. And the 2 we already know because we have that x minus 2. The other ones let's write as x minus r. So we have x minus -4, which will become x plus 4, right? X minus -3, which becomes x plus 3. X minus 2, which, well, we already had that, so I don't need to rewrite it. And then we have x minus 6. Okay, so if we write this in fully factored form, it's x minus 2 times x plus 4 times x plus 3 times x minus 6. If you want to do it using synthetic division, you would start off with 2, right? And you would reduce your polynomial. So we would reduce, like, make these coefficients 1, and we do 1, 1, 1, -1, -32, -12, and 144. So remember, we start off by bringing down 1. 1 times 2 is 2. -1 plus 2 is 1. 1 times 2 is 2. -32 plus 2 is -30. -30 times 2 is going to be -60. And -12 plus -60 is -72. -72 times 2 is -144. So now we have a remainder 0, as we should. And remember, the polynomial goes down by degree 1. So we have x cubed plus x squared minus 30x minus 72. So now we need to find a root of this polynomial so that we can reduce it further. So what we do now is just go ahead and use Desmos, unless you want to use the rational root theorem, because then you do plus or minus the factors of 72 over 1, and you could figure it out that way. But it would involve a lot of trial and error, right? Okay, so here we have minus 72. So just pick one of these roots. I'm going to pick 6. And so then you just do synthetic division again. So you have 6. And then when we do the coefficients of now this polynomial, we have 1, 1, -30, -72. So we bring down 1. 1 times 6 is 6. 1 plus 6 is 7. 7 times 6 is 42. -30 plus 42 is 12. 12 times 6 is 72. And so you add them together and get 0. So we have x squared plus 7x plus 12. And now this we can factor using those quadratic factoring methods. So that's why our goal is always to get to a quadratic trinomial, right? So then we can just rewrite this as x plus 3 times x plus 4. And you'll notice that this 6 is going to be an x minus 6 factor, and this 2 is going to be an x minus 2 factor. So you see, if we gather them all up, we get the exact same answer that we did when we used Desmos. Okay. All right, so this says, which is a zero of the polynomial function? The quickest way, like I said, to find zeros is just to go to Desmos and type in this function. So we are typing this in now. So we have x to the fourth minus 5x cubed. My 5 is not showing up for some reason. Okay, there we go. Minus 13x squared. And then we have plus 77x and then minus 60. Okay, so all of these are zeros, right? Zeros are places where the graph crosses the x-axis. So we have zeros at -4, 1, 3, and 5. So the only number that's on that list is 3, so that's the correct answer to this problem. Now it wants us to multiply. It gives us two binomials, right? So the quickest way to multiply two binomials is to use FOIL. So we do first times first. So 3x times 8x. So that's going to be 24x squared. And then we do the outside. So 3x times -5. And so that is -15x. The inside is 7 times 8x. So that is equal to 56x. And then the last is going to be 7 times -5. And that's going to be -35. Okay. Remember, whenever we do this, we actually add up all the terms. So we have 24x squared minus 15x plus 56x minus 35. Okay. These two middle terms will combine. So we have 24, whoops, not 2x, 24, 24x squared. And then we have 56 minus 15. So that's going to give us 41. So we have plus 41x and then minus 35. Okay, so that is now the product we get when we multiply these two binomials. Okay, so now it says to divide using synthetic division. So this is an x plus 3, right? So that means like in x minus r terms, that means that r equals -3 because it's going to be the opposite sign. So we put the -3 in the corner. It is in standard form, but we need to add in the coefficient of 1. So we have 2, -1, -16, and 15. So I'm going to start off by bringing down 2. 2 times -3 is -6. -1 plus -6 is -7. -3 times -7 is 21. So -16 plus 21 is 5. 5 times -3 is -15. So that gives us a remainder now of 0. So remember, every time we divide, it goes down 1 degree, right? This is x squared, this is x, and this is the constant. So we have 2x squared minus 7x plus 5, right? And there's a remainder of 0, so we don't need to write anything. That is our answer that we get when we divide. Okay, so that's all the problems in the review. So please reach out if you have questions on anything.